Look at Spearman's rank correlation coefficient and how to calculate it using your Casio CG50 calculator. And then we'll look at some exam questions on how to answer them. So, previously you would have learned Pearson's correlation coefficient, which we differentiate between Spearman's and Pearson's with a very logically labeled RP and RS, S for Spearman, or P for Pearson, right? Pearson would have been calculated using the X and Y values, right? You would input it into your GDC, and then you'll get this R value in your calculator. Now, Spearman's is a little bit more different. Spearman's rank is basically finding the strength of the correlation between variables, just like the Pearson's version. But the difference is it's the variation using the data that is ranked in order from small to big, or it could be from biggest to small. So you're going to rank your data in order, and then you input that rank into your calculator, not the actual data itself. So the difference between Pearson and Spearman is that whilst Pearson is limited to linear data, right? We talked about how it's one of the limitations of Pearson's. If it's not linear, it's likely to be unreliable. Spearman's doesn't matter whether it's linear or not. It can be used for any sort of bivariate data. Let's take a look at how you would use this in order to answer a question. Exam start question. So, here's a question. The amount of dry matter in tomatoes measured in grams is the amount of solid content of the fruit. Subtract the water content. The table below shows weights of dry matter in 10 tomatoes grown in soil with different amounts of calcium measured in magnesium per centimeters cubed. So this is the weight of the dry matter and the calcium in soil. All your questions for bivariate statistics are going to be in this kind of form with kind of like a word sentence on top, which you need to comment on. You see, you'll notice this on all the questions. So you need to make sure you understand what the question is talking to you about. First of all, we're going to calculate the Pearson's coefficient. I chose this question because you need to calculate both and compare. So it's useful to understand the difference between the two. Now remember, we label it as RP. And let's find the value first. So we're going to get our calculator, and then we're going to input this value into our GDC. Remember, this is going to be in the X list, and this is going to be in the Y list. So if we go into menu, we're into statistics, you can press exit to get out of this. You can use this to get to the top of your data, delete all the previous data that you had previously inputted, and then let's put in the values. So it's 12, 13, 15, 17, 18, 19, 21, 22, 23, and 25. That's list 1 for our X values. And our Y values, these are the weights of dry matter this time. 2.9. Make sure to just put them in chronological order as they appear in the table that's provided. So 3.1, 4.7, 4.5, 4.7 again, 5.3, 6.1. I'll talk about what happens when you have repeat data, because for Spearman's data correlation, because you're ranking them, it's quite important what you do using that data. 6.5, 6.7, and 6.8. So now we're going to calculate Pearson's coefficient using our GDC. So if we normally, you'll be on this screen, you're going to press calculate, regression line, and X, AX plus B, and you'll get R value of 0.9734. 0.9734. Remember, we're always to 3 significant figures, so 0.973 would be our Pearson's coefficient value. comment on the strength of the R value found. It's going to be a strong because it's very close to 1, right? And it's a positive correlation because it's not a negative number, right? Now here's how to calculate Spearman's rank correlation coefficient. You're going to rank each of the data in order. If there's no mention, you can just order it from smallest to biggest, but it doesn't really matter. Let me just get rid of the previous question just to have some more space on the page. So, ranking from smallest to biggest, we can see 12 is the smallest, 13 is the second largest. So conveniently for us, at least for the top row, it's been ranked in order of smallest to largest already for us. Although the one below that hasn't, so 2.9 is the smallest, then we have 3.1, then we have 4.5. Now notice how 4.7 and 4.7, we have two values that are identical. We're not going to put fourth and fifth like that because that would change our results. Instead, what we do, because they would have been the fourth and fifth positions, we're going to add them, divide it by 2 to get the average. Then we're going to put the average, which is going to be the same for both. And because they would have been the fourth and fifth positions respectively, we can just move on to the sixth position straight away. Just like so. And then the seventh, and then the 8th, 9th, and 10th. Now we've ordered them in order, ascending order from smallest to largest, right? Now we're going to input each of these values, not the original data, into this. So this would be our X values, and this would be our Y values. So list 1, and this would be list 2 in our calculator. So if we go back, we can exit, and we can delete all the previous data that we had previously inputted. And then we're going to put in our X values. So the list 1 was just 1, 2, 3, 4, 5, 6, 7, 8, 9. I think we had 10. Yep. It was just in order already for us. And now we can put in the second one as well. Make sure to put them in the order that they appear. So 1, 2, 4.5, 3, 4.5, 6, 7, 9, 8, and 10. So now that we've inputted all our values, we can again press calculate regression x and ax plus b, and we get a new regression line of 0.9665. So our Spearman this time 0.9665, and to 3 significant figures as we always do it, 0.967, which we can write down over here. And for reference, our Pearson's value that we obtained was 0.97. I forgot the third digit was 4 something. I haven't written it down separately, so 0.974. Now we can comment on the strength of the R's value found. Likewise, it's going to be a strong positive correlation between your bivariate data. Now this is the most important part. This is why I picked this question out. And why I picked it out is it's very important. In the context of this question and the data provided, comment on if both correlation coefficients should be considered when determining the relationships between sodium, calcium, and dry matter weight, or if one should be used in favor of the other. Essentially, it's asking us to compare which one is better, if that's the case. But because they both have 0.97, 0.9, so they both have a very strong linear positive correlation. Remember, the reason the Pearson might be inaccurate, unreliable, is if it's non-linear data, if there are anomalies. But because there are no anomalies, because the data set is linear, both, okay, so the point is they both have a strong linear positive correlation. Hence, either is adequate. There is no difference between the two. When there might be a difference is if this value was non-linear. So if we got a value like 0.51, it's not very linear, right? Then it'd be better to use Spearman's, because Spearman's is not affected by whether the data is linear or non-linear. That's quite a long question, but it gives us some good comparisons that we need to make, which is quite useful for this topic. So it says a snack company is trialing a new series of crisp flavors. The 8 flavors have been assigned letters A through to H, and now we have 3 people who are scoring each of these flavors on a score of 1 to 10. 1's hated and 10's the best. So Idris, Jamil, and Kevin each try flavors A to H, and they rate it 1 to 10. So for example, for flavor A, Idris hates it whilst Kevin loves it. That would suggest, at least based on this alone, they have a strong negative correlation. What one likes, the other's going to hate. What the other hates, the other's going to like. At least in between Idris and Kevin for this specific flavor. The company would like to find Spearman's rank correlation coefficients for these taste testers' rankings. Complete the information in the following table. So conveniently for us, they have given us a separate table in which we can fill it out with, which is quite nice of them. So Idris's rank, remember, these are all separate to each other. So for Idris, we're going to rank his individually from smallest to largest, and Kevin, we're going to do the same. So they said A is 1, E is 8. So we have A, B, C, D, E. I think we have 8 pieces of data. Yeah. And if, let's say, they had chosen to label A as 1 and B as E as 1, because E was the biggest data for Idris, right, and A was the smallest, that would mean they want us to rank it in descending order. But because they ranked it as A as 1, it's in ascending order. So smallest to biggest. So 1's the smallest, the second biggest value is F, so F would be 2 over there. And you're just going to fill it out in ascending order. So 3rd, 4th, 5th, and we've got 6th and 7th. You're just ordering it from smallest to largest. I've done this previously, so I'll just fill out the data as to save time. So 4, 3, 5, 7, 2, 6. And Kevin's going to be 3, 6.5, 2, 4, and 5. If I just talk about this 6.5, it's because they have 2 pieces of data, 7 and 7, that are the same. They would have been the 6th and 7th position respectively. So we're going to add 6 plus 7, divide that by 2, which is 6.5. So they're going to both be 6.5, and the 7th value just continues on from there on. So sorry, 6 plus 7. So the 8th value is just going to continue on from there, which is over there. Okay. Now we're going to find Spearman's rank correlation coefficient for these values. So for example, for Idris and Jamil, I'll just do 1. We can input, we can exit, we can go out, delete the previous data that we had previously inputted. And for Idris, Idris would be on list 1 this time, and Jamil would be on list 2. So 1, 7, 3, 6, 8, 2, 5, 4. And likewise for Jamil, 4, 3, 1, 8, 5, 7, 2, 6. We can press, usually you'd be on this menu, you press calculate, regression, x, and ax plus b. And we can see 0.04761. So R for Spearman, remember they asked 0.04761. Remember, always 3 significant figures, so 0.047. Remember, the first 0 doesn't count, so 6 would be the 3rd significant figure. And you can do the same for all your other values, and once you input them, you'll get negative 0.970 for this one. And for this one, you'll get negative 0.24, just to save some time. Now it asks us, comment in the context of the question on the results obtained for RS and part BI. So comment on the results we've obtained here. So for example, we're going to have to comment on Idris and Jamil, Idris and Kevin, and Jamil and Kevin. Well, between Idris and Jamil, the value is 0.476, right? So there is very little correlation, 0.0, it's not even 0.1, it's 0.04. So there is little to no correlation between Idris and Jamil taste preferences for chips. There's very little, and there's zero correlation. This means, remember, for comment questions you have to refer back to the context that you're provided with. This means it is hard to predict based on what other likes. What one will like based on the other. That is the kind of expectation. So if we look at Idris and Kevin, I'll just say it instead of wasting some time and writing it down. We can see negative 0.970. It's very strongly negatively correlated. Idris and Jamil's taste preferences are strongly negative correlated for chips. This means what Idris likes, Kevin hates, and what Kevin hates, Idris likes. So, and vice versa. So it's a strong negative correlation. For the last one, it's negative 0.24, so it's a relatively weak negative correlation. Idris hates what Kevin likes, and vice versa. So there's a slight tendency for one to like what the other likes, and vice versa. So just refer back to the context of the question. Now this is the important part. It is noticed that a greasy fingerprint has caused Kevin's score of 9 to be misread. The score actually assigned by Kevin to flavor A was 8. So flavor A, Kevin had actually assigned this as 8 instead of 9. Let's make it visible, so it's going to be 8 instead of 9. Explain, with a reason, whether this will change the values of Spearman's rank correlation coefficient. Would this change it? Remember, Spearman's rank correlation is based on the ranking of the numbers in order, right? So A value was 9, and it was the largest value, the highest score that Kevin gave out of all the chips. Even if the score changes to 8, it's still going to be the highest. Therefore, the ranking itself wouldn't change, which is what we use to calculate the Spearman's coefficient. If had it been changed to 5, then the coefficient would have changed. But because 8 is still the largest number and the rank itself wouldn't change, there would be no change to the Spearman's rank as well. Therefore, we can say, no, it will not. And as either way, regardless of flavor A score being 9 or 8, it is the highest, still the highest for flavor A, regardless of whether it is 9 or 8. So no change in the coefficient in Spearman's ranking. That is pretty much all you have to know for Spearman's coefficient.